You send a string. You get a string back. Between those two strings sits a pipeline that turns text into numbers, runs a trillion parameter forward pass, samples one token, and repeats. This episode opens that box. Every LLM call walks the same 5 steps. Tokenize, embed, forward pass, sample, detokenize. Tokenize splits your prompt into integers from a fixed vocabulary. Embed maps each integer to a vector of around 3000 dimensions. The forward pass runs those vectors through stack transformer blocks and produces a probability over every token in the vocabulary. Sample picks one token. Detokenize turns it back into text. Then it repeats for the next token. That repeat is the whole cost story. Prefill processes your entire prompt in parallel, fast. Decode emits one token at a time, each step waiting on the last, slow. That is why a 4000 token prompt with a 50 token answer is cheaper and faster than the reverse, even at the same total. Tokens are not words, they are subword units learned by byte pair encoding. BPE starts with raw characters. It scans the training corpus for the most frequent adjacent pair and merges it into one new unit. Repeat 50,000 times. The vocabulary that drops out covers common English words as single tokens and rare words as sequences. The word tokenization splits into tokenization. The word the is one token. A leading space is part of the token, space the and the are different IDs. Implications matter for engineers. Japanese and Chinese take 2 to 3 times more tokens than English for the same meaning. JSON with verbose keys beats tokens. Count before sending with tick token or the provider's tokenizer. Cost is measured in tokens, not characters. Embeddings are the bridge between language and math. Every token becomes a vector. Every sentence, paragraph, or document can become a vector too. The classic example is vector arithmetic. King minus man plus woman lands near queen. The embedding space encodes relations, not just labels. Modern embedding models produce vectors of 700 to 3000 dimensions and similar meanings clustered together. To compare two embeddings, take their cosine similarity, the dot product divided by the product of magnitudes. 1 means identical direction, 0 means unrelated, -1 means opposite. That single number powers semantic search, recommendation, deduplication, and classification, all without keyword matching. Cluster customer support tickets, find duplicate documents, route queries to the right tool. Every retrieval system you will build sits on top of this geometry. Now, the part you actually type. Every modern LLM call is an HTTP post with a messages array. OpenAI calls it chat completions. Anthropic calls it messages. The shape is nearly identical, a system prompt, a list of user and assistant terms, a model name, temperature, and max tokens. OpenAI's client.chat.completions.create takes model, messages, and temperature. Anthropic's client.messages.create takes the same arguments with one swap. The system prompt is its own top-level field rather than a message. StreamTrue lets you render tokens as they arrive instead of waiting for the full reply. Response format equals JSON forces structured output. Tool definitions enable function calling. Behind every wrapper library, LangChain, Llama Index, Versal AI, SDK sits this single HTTP contract. Embeddings live somewhere. That somewhere is a vector database. The contract is 3 operations. Upsearch stores a vector with an ID and metadata. Query takes a vector and returns the top k nearest neighbors. Delete removes 1. The trick is the index. Brute force comparison against a million vectors takes a million dot products per query. Approximate nearest neighbor indexes. HNSW or IVF cut that to a few hundred by trading a sliver of recall for huge speed. Pinecone, VV8, Kudrant, and PageVector all expose this same shape. If you already run Postgres, PGVector is the zero friction start. The contract above is what every retrieval augmented generation system depends on. That is one LLM call, tokens in, tokens out, vectors everywhere in between. Next episode, prompting fundamentals, how the words you choose reshape what comes back.